Hi, everyone. Welcome to this afternoon's Zero Emissions Building Feedback Session, virtual. This is being put together by Department of Neighborhood Development, Placetailor, Thornton Tomasetti, and we'd also like to acknowledge the BPDA and the Office of the Environment. Today's presenters are Travis Anderson, that's myself, the Director of Innovative Design at Placetailor, Colin Sless from Thornton Tomasetti, and Jay Lee, the Assistant Director of Design Construction Open Space at D&D. This session is actually session number 4. We've had 3 previous stakeholder sessions. 1 and 2 focus largely upon the initial modeling results, and we gained feedback from a variety of architects, general contractors, engineers, HERS raters, to help kind of influence what would end up going into the guidebook and recommendations. Session 3 was mostly developers and CDCs that focused largely upon the cost analysis and feedback, as well as the recommendations that we were putting in place. And this session 4, and we'll be doing another one similar to this next week at the same time on Friday, focuses on the guidebook itself. And we're looking for basic feedback, content clarity, what works, what doesn't, because this is a very important document. And we just want to make sure that it's well received and understood by all the parties. So I will pass it over to Jay in a second. First section of the session will be why are we here, which Jay will focus on. Section 2 will be about the zero emission study summary and key findings that Colin will discuss. And then section 3, I'll go over the guidebook and design and content. And we are hoping to leave section 4 for all questions and feedback. So as we march through each section, feel free to input your questions, but we'll won't pause until we get to section 4 to go over them. And it would be actually really helpful if all the participants can use the link that was provided in the BSA to the full guidebook, because we won't be able to view all 85 pages of it during this time. But if there's anything specific in regards to what you see in the guidebook, please go to that and the feedback section on the D&D website to post any more comments. So now I will pass it off to Jay so we can talk about why we're here.
Thanks, Travis. I also wanted to welcome everyone to this virtual session. It's a little bit odd, but we're all getting used to it. I'm also very excited to hear the feedback from our study and our preliminary guidelines. I want to provide a quick overview of how we got here and then turn it back over to Travis and Colin to get more in depth to the study. You can go forward. In 2017, Mayor Walsh had the goal of Boston being 100% carbon neutral by 2050. He's been a champion in leading that effort. Go to the next slide. The mayor brought together a green ribbon commission to assess strategies to achieve this goal. Keep going. The commission came back with conclusion that Boston needs to pursue 3 strategies simultaneously: reduce demand for energy by increasing efficiency, convert nearly everything that runs on fossil fuels to electricity, and buy 100% clean energy. They also had the feeling that any new building that's not net zero today is a building that we'll have to retrofit in the future. That's important. So with the leadership of Chief and Director Sheila Dillon, we've been working with Placetailor and Thornton Tomasetti to study zero emissions in the affordable housing typologies we typically fund and develop design guidelines for implementing zero emissions strategies into our building projects. So with that, hoping we have a really interesting discussion We really are looking forward to your feedback, and I'm going to turn it back over to Travis and Colin to talk about the rest of the project.
All right, section 2, we'll have Mr. Colin Schless jump on board here and go over our process and key findings on how we got here.
Sure. And apologies for our company name can be a bit of a mouthful. TT is sufficient. That's a little easier on the tongue. But anyways, what this first graphic is a little cartoon we made of our process so far. And all the way to the left is when we kicked off in June 2019. And at this point, there were kind of the what are we doing meetings. There was this really ambitious goal of carbon neutrality for the housing stock. But we weren't really sure what carbon neutrality meant, how we were going to get there. We went into a fairly deep analysis process that Travis referenced afterwards, and we're going to talk a bit about that. And we had this process of reviewing results. We just kind of churned them over and over and over again. There was a big data set, and tried to get something sensible out of them. And we feel we did, but of course, that's what we'd like feedback on. Once we had our kind of numbers baked from that study of what the ingredients to a zero carbon housing stock would look like on a building by building basis, we wrote standards. So Travis is going to share some of those later. That includes details, that includes execution plans for how you can actually implement some of this stuff. And then of course, stakeholder review. And the initial draft of this has been published, and this is kind of the follow-up to that, of course, where, again, soliciting additional feedback. Next slide. Okay, the city of Boston, extremely progressive on the energy front, with the exception that it appears that streetlights go on a little bit too early in this picture. But if you go to the next slide. Boston has a lot of accolades in terms of energy efficiency. I spent the past 4 years in the Bay Area in California, which was, between Title 24 and California's policies, is an extremely progressive place. But lo and behold, moving to Boston actually takes the crown. Boston has kind of led the charge as most energy efficient city for the ACEEE, which is not an easy thing to achieve. So quite impressive. Boston's achieved a number of its targets ahead of time in terms of climate goals. Next slide. This graph sums it up well of how Boston has got there. That orange line there is the line to the 2050 goal. 2050 is this kind of shared timeline that a lot of cities are talking about to achieve carbon neutrality. And the kind of jaggedy line there shows total emissions, and it's more or less been following that trend, which is a good thing. I see there's a question. Maybe I'll why not use the FIAS as the standard? It is performance based. I'll definitely talk about that. That's certainly something that we talked about. Primarily, the reason why we didn't use FIAS as a standard is that FIAS and pass-to-pass compliance requires an energy modeler on the project. And, being an energy modeler myself, I think it's a critical part of the process. But when I drive down the road and I think about how many buildings actually had an energy modeler, how many even had an architect, it's very few. So the hope for this standard is it's more of a prescriptive standard, which FIAS doesn't currently offer. I'm on the technical committee for FIAS, and we're actually discussing scripting a prescriptive standard, but we're not there yet. So the idea of this standard is that nobody needs to do energy modeling. We're just kind of telling people a formula here in Boston, what you need to do for a building to get to our targets. So hopefully that explains a bit. Anyways, in terms of Boston's approach to carbon neutrality and reducing the size of our environmental footprint, it just hasn't been narrowly focused on carbon emissions, right? It's multifaceted. Here in this cool little graphic that the city produced, you can see that it's everything from waste reduction to mobility. So next slide. But here's the catch, right? With that curve that's going down really well in that graph behind us, there's some fine print. If you look at the bottom of this, it says over 45% of past emissions reductions were due to a cleaner electricity grid as power plants have switched from coal and oil to gas. So look at that clean electricity at the top there. If you go to the next slide, that was all kind of the low-hanging fruit that we did. Now the question is, how do we make that dotted line happen, right? How do we go from where we are now to zero? And that's where we really need to start drilling in on our buildings. And that's where the impetus for these standards came from. Next slide. Okay, very quick, carbon dioxide or carbon dioxide equivalent 101. This is probably routine for a lot of folks, but at the same time, as carbon is becoming a metric that we're using more and more often alongside things like EUI or dollars of energy use, we're finding carbon dioxide, a lot of folks don't have kind of intuitive sense for it. So I just want to do a quick overview of where we're coming from with that. Next slide. Okay, carbon dioxide at kind of a very high, this is like second grade science level, it occurs naturally. It's an odorless, colorless gas that occurs naturally in our environment. There's very natural carbon dioxide flows, right? Trees sequester carbon dioxide but at the same time, we breathe out carbon dioxide, right? There's this natural carbon cycle. The ocean does a really similar thing. And it creates this thing called the greenhouse effect that keeps our planet from being like, incredibly cold. I think it's like ends up being 0 degrees Fahrenheit or something like that without our kind of nice layer of carbon dioxide and its other greenhouse gases. The issue is that 29 that spikes up over by those cities over there is that although small in the greater picture, that creates an imbalance. Next slide. With that imbalance, we increase that greenhouse effect. We're now taking all that heat from the sun, we're capturing it, it stays inside. Next. And what the impacts of that, of course, are things like melting icebergs, sea level rise, increased storm events, all things that we're already feeling very much so here in Boston. Our office is in the seaport, and some of the pictures from that bomb cyclone that happened recently were a little bit unnerving. Oh, Travis, are you pushing me along? Am I slow? All right, sorry. Anyways, so Boston sat and said, what should we do about this issue? What does our carbon footprint look like? And it turns out about 70% of our carbon footprint is due to houses. So it's both small residential and commercial industrial. Next slide. So in our meetings, we asked the question, what do we actually mean by net zero? Because the city has a few definitions. Next slide. Of those definitions, just to go over it quickly, going from left to right, there's ZNC onsite, which means that there's photovoltaics on your rooftop, and those are providing as much energy as the buildings below are using. Sorry about those little formatting bumps here. The next one is onsite and offsite. So that means that you do have some amount of renewables on site, but you're not able to provide the total demand of the building with them. So you have to go offsite to supplement that. The third definition is ZNC ready, which is effectively an all electric building that can tie into a clean grid once it's available. And the last one is ZNC convertible. That's a project that for certain reasons may have to tie into natural gas now, but is prepared via conduit or whatever it is, transformer size, to accommodate an all electric conversion at some point. We had to decide which one of these made the most sense. Next slide. And pretty quickly, we decided, let's strive for the more stringent of these, either ZNC onsite or a ZNC offsite. Next slide. So with that said, okay, let's say we can put PV on a rooftop. The question is, what does the building look like below, right? And that's really what we're here talking about. Next slide. So we did a bunch of analysis and reviewed the results. Next slide. We're going to talk about that a little bit. But we used some of the basic principles of Passive House. Somebody brought that up before, where thermal bridge free optimization, insulation, passive cooling, air tightness, heat exchange ventilation, rooftop PVs. These are all the things that we started to check off. And next slide. We looked at 4 primary typologies. We looked at a townhouse, a 3-story multifamily building, 4-story multifamily building, and a 6+ multifamily building to understand kind of like what are the nuances, the sensitivities with each one of these. Next slide. And then the next thing we did was we stuck as much PVs on the top of them as we possibly could. And we said, what does it take to get to net zero for each one of these projects? What do the buildings actually look like? Next slide. And you run into this problem with net zero, right? You've got these small buildings where maybe they're producing 60,000 kilowatt hours on the roof, and they're only using 30,000 kilowatt hours underneath, well, you're now net positive, right? You're 30,000 kilowatt hours in the bank. Perhaps you go a little bit taller and you're neutral, but the minute you get into larger high-rise applications, especially in an urban setting with shading nearby, you start to hit a deficit, right? No matter how much PV you put at the top, you just can't neutralize your energy use. Next slide. And another way to look at it is looking at the impacts of the building below, right? So with our townhouse, the townhouse had to be a bit high performance. The slightly larger building had to be pretty high performance. The larger multifamily had to be very high performance. And then when we got to the tall buildings, it was impossibly high performance. So we said, okay, this is tricky, right? How are we going to get to net zero with all these things? Next slide. Then we had this idea. We said, hey, what if we look at the entire upcoming stock of buildings and look at the cumulative production of PVs on the roofs of all of them? And, he said, hey, we've got this huge number of kilowatt hours produced. And he said, how many people are going to be in these buildings? We counted up the total number of people in those buildings, and we just divided one by the other. Next slide. And what that offered is it offers a budget per person, right? That's a CO2 budget per person. And why this is interesting is that if we set EUI and energy use targets for buildings, it effectively disincentivizes tall, dense buildings. But by changing it per person, if you have a building with more people in it, that gives you more of a carbon budget. So it's more accommodating to those building types. The idea is that across the portfolio, it nets out to zero carbon. Although some buildings may be positive, some buildings may be negative, the whole portfolio balances itself out while encouraging urbanization, densification, all these things that we see as positives to our social infrastructure. Next slide. So we came up with that number, 0.77 tons per year, and we really kind of came out of the blue. We came back in, again, somebody referenced FIAS. FIAS had a big research study with the Department of Energy, and they came up with their own budget for study purposes. And it's pretty interesting. Them and the UN kind of come up with this idea that everybody uses about 3 tons of CO2 per year in a sustainable society. And buildings should use about 1/3 of that. So that puts us at about 1 ton of CO2 per person per year for building energy usage. Actually, it's 0.7 to 1.1. And lo and behold, we fell right in the middle of that. We ended up at 0.77. So we didn't start with that, but when we did our kind of checksum at the end, yeah, we're very consistent with it. So that was exciting. Next slide. So the question remains, with that formula, 0.77 tons of CO2 equivalent per person, what does that mean for the buildings below? And how did we get there? Just a quick bit on process. To get there, what we did is we did these big batch parametric studies. So we built an energy model of each one of those topologies, and we simulated each one probably about 80,000 times. We ran a batch script, so the thing just goes and runs through. And then what we can do, this is called a multi-dimensional visualization. We get results for 0.77 tons per person, and we can strike down on those results. And to the left, what you see is all different formulas that will arrive you at that energy footprint. Next slide. And here is a picture of the type of outputs that we came up with. And Travis, should we switch gears? I don't know if you want to go through these, but in each one of these tables, just a high-level summary, the yellow arrows indicate what is becoming more stringent from a 2019 stretch code to zero carbon, and the blue arrows actually show certain things that got relaxed, because as we're going through in the parametric study, the sensitivity analysis, we learned that some of the things are not, their roof insulation, for example, we were finding is not as important as some of the other components. Yeah, under slab floor R value, that was another significant one that we found could be brought back. Okay, and then the last thing we did is we did a bit of a sensitivity analysis on ventilation rates and window to wall ratio. We got some interesting meta findings from this. One of them was that a window to wall ratio in the low 20s to high teens was by far the most affordable way to achieve this standard. Based on the designs that wasn't onerous compared to what people are used to designing now. I'm curious if people have comments about that. but that is what we are finding. And then in terms of ventilation and the requirements on projects, once we jumped up to a 4-story multifamily and 6-story multifamily, it was apparent that ventilation rates increased significantly. And part of that is that we now have corridors and common spaces that we need to ventilate, which adds to the overall airflow of the building compared to just simple residential and laboratory uses. Okay, next. Right, there's the standard. Next slide. And yeah, this is kind of just some of the summaries of all that stuff I was just yakking about. Yeah.
All right, thanks, Colin.
Thanks.
So now we took all these findings and then applied them to what we're calling the guidebook for these recommended standards. We'll kind of march through some initial pieces of it and then highlight one of the selected buildings that we analyzed, the 4 to 6 story. So initially, the concept for this was to make it as simple and pared down as we possibly can. We wanted this to be a booklet that what we like to call the average Joe builder could take and take some kind of prescriptive assemblies and tactics in order to reach to this level. Because as Colin mentioned earlier, a project that's probably a 6-unit townhouse or even a smaller multifamily might not bring on full energy modeling, especially during the early stages. Now, with this more incentives available in the state of Mass is offering for passive house analysis, it's great because it does help cover that modeling fee that otherwise might not be accessible. But again, we're using this booklet as a way to kind of highlight and introduce key concepts so people can take the initiatives on. So this summary starts out, we kind of begin talking about the process that Colin went through and summarize this building by building approach early on into the booklet, just to show part of our process and how we started getting to the 0.77 concept. The next page references back to this 0.77. And again, it's starting to highlight a lot of the elements that we talked about earlier. Part of the reason why we wanted to show this in section 2, how we arrived at this, was to see from the viewers out there if this is actually being conveyed in a simple fashion without us narrating above it. So we want to make sure that if you have the chance to go through and read the document, to make sure that it's conveying the language and highlighting a lot of the key topics and definitions that we were talking about earlier. And then again, we're looking at the kind of the high level building portfolio concept. So we're really kind of driving that home because this is really about the portfolio of D&D and what's available and coming up in the pipeline. So we fortunately had all that data and sites plans from Jay that D&D provided, which allowed us to develop this portfolio concept. And then further on into the booklet, we start getting into our cost analysis and how we started to analyze them and look at them. One thing that we wanted to really point out and highlight was that air tightness, or ACH, was a big element to what drives these buildings to be successful. And as you can see in the bottom right-hand corner, there was a study that was done by 475 using PHPP software, which is Passive House Planning Package for Passive House International, and was looking at how increased air tightness does affect the same wall assembly. So using the same exact wall, but increasing air tightness drove heat demand down considerably. And that again ties back to the EUI, which again can tie back to the carbon per person metric that we're looking at. Other elements that we analyzed were materials, which were based upon 2019 cost pricing. Labor, we flattened the labor rates over every single project in order to sort of equalize that. So that's where bids may differ because of an understanding of labor and what it takes. Systems, we took those down and broke them to a per unit basis. Renewable energy, we did not include any of the incentives available that are currently on market just because they continue to evolve. And I think they've even changed since we started looking at this document. So it was fortunate that we left them out because otherwise our pricing might not have been as accurate as it shows. Windows, we did per unit. Again, air tightness, going back to that, we saw a lot of that was affected sort of by middle management or QA, QC on site. If you read through what is required by code, the materials and everything that you need to supply to achieve air tightness are there and are required. So we saw it more as a detailing issue and also the QA, QC on site. So that's where we saw some increase in terms of air tightness. And then also looking at heat recovery ventilation, domestic hot water, heating systems, and overall assembly R values. And another thing that we wanted to highlight was that we see this as an opportunity to encourage education and training for labor so that over time, it'll help to even make this more cost parity with current building practices as people get trained and start to understand these assemblies more so. So overall, through our analysis, we've started to see a 1 to 2% cost increase to reach the zero emission building. And then this is highlighted further in this chart where we look at the differences between the stretch code baseline building and the zero emission building. As you can see through the stretch code, we're looking at EUIs in the mid 20s to 30s range for each building typology we looked at. And then below that shows the CO2e per person. So we're at about 0.86, 1.19, 0.8, and so on as we go through them. And then working down further, we get into the zero emission building energy use intensity. So we can see that we're starting to get a drop there as we get to zero emission, going from 24 to 18, 34 to 26, 25 to 21. And that's also putting us on that 0.77 target. Another important thing for us to look at was the annual utility cost per unit. So in this terms of the stretch code, we're looking at that as far as heating and hot water is concerned. So we're looking at a therm value. So we were seeing, based on current utility rates, about $1,800 annually for the small multifamily. The 3-story was coming in about $1,200 annually, 4 to 5 story, $1,300. And then working down to the zero emission building, we also started seeing a decrease in costs. So if the owner was to carry the cost in terms of overall operations, and it's important to highlight here that we're looking at both the heating and cooling loads, along with domestic hot water and plug loads in terms of operations. So we started to see that the numbers are starting to drop just because we were gaining efficiency in terms of overall heating and cooling needs, as well as what we were finding with hot water. So overall, we started to see these decreases going from the incremental change per person for each unit in about the 20% range. And then the incremental cost to get the ZEB, or a zero emission building, we were seeing about a 0.8% increase, 0.9% increase for the small 6-unit building. The 3-story multifamily, we were seeing about 0.5%. The 4 to 5 story, about close to 1%, and then the 6-story multifamily close to 2.2 or 2.5. And these increases in cost, we have seen them being backed up by other studies out there, like the USGBC Mass study, as well as we've heard other passive houses being put in place, being built for around that 2% cost, especially when you're up to the 4 to 5 story or even 6-story to reach passive house level. So that's very promising because we're starting to see a lot more cost parity, and it was important to us to highlight and show that it's achievable simply by kind of following these standards that we're going to go through. Again, this is referencing back to a lot of the modeled results and highlights that we saw that Colin was referencing earlier. This is just kind of brought forward early on in the pamphlet. And then we get into section 2 of the guidebook, which is best practices. So here we're talking about what is a zero emission building.
Hey, Travis, if I could just interrupt you for a second, I'm watching the questions come through.
Sure.
And I want to, let's see, I got to look through here. There's a question, are these actual construction costs or in real utility data? Since you guys were kind of quarterbacking the construction cost side, do you want to answer that one?
Yeah, so in terms of construction costs, I'll go back to the chart. We were using current material pricing and what was available on market. So we wanted to make sure that anything that we modeled in the background was a real and actual building that we could then assign pricing to. So we used a lot of kind of broad standards across the industry to look at the cost matrix and get that analysis. What was promising to us again was that it's been backed up by other studies too. So we weren't just an outlier in our findings to achieve this level of cost. So hope that helps.
Let me just do a couple more of these questions. Yeah. Let's see, there's another one that says, is D&D going to allocate carbon to owners using their funding? How will they manage this? I can try to take a stab at that. It seems like there may be some misunderstanding on the concept. The concept of the portfolio is that it will be carbon neutral based on the PVs that are on the rooftops of the buildings and the demand from the buildings below. So there's no offsets that are associated with this approach. So maybe that addresses it. There's not going to be any kind of allocation of carbon. It's basically that budget of 0.77 will apply to, applies to all the projects, and they should be able to hit it should they follow this recipe. Right. And then the one more that I'll check off, hopefully I'm not losing track of anybody's. If I am, please feel free to type it in again. But it says, does a 6-story multifamily assume all wood construction or with a podium? The 6-story does have a podium, but we removed any retail or commercial space from the model. We wanted to focus on residential only. There's just too many variables. I mean, if you put a fast food restaurant in there compared to, geez, I don't know, like a convenience store, the energy profile is so radically different. So that topology that was omitted as a control, but that is the construction. Oh, and it looks like yeah, okay.
Okay. So just going back to the definition of what a zero emission building is, it prioritizes thermal bridge free and airtight construction, prioritizes an all electric system and heat exchange ventilation, prioritizes on-site renewable energy generation, evaluates embodied carbon of all materials, and it, to Colin's point, we said it can include off-site renewable energy and carbon offset as necessary, but through this formula that we came up with, we don't see that as a need unless it's driven by extreme site constraints or anything. And I think, that's something that we could, Jay and the folks at D&D can also take a look at in terms of that need. So here we're just going through kind of architecture 101, kind of key strategies for massing, simplifying the form. So we look a lot at surface to volume ratio in terms of high performance buildings. So the more kind of push and pull that you do, you kind of get that sad, more difficult building that it's harder to achieve this matrix. Orientation, given that a lot of sites are driven by urban infill, this is one where we don't have the advantage of kind of open site. So you might end up with a building that's more east-west, or might just have a lot of north orientation for any given reason. So that's where a certain set of criteria in terms of looking at window to wall ratio and maybe the overall assemblies might come more as more of a factor. And also, again, going back to the carbon per person, looking at impacts of unit density and sort of what that means in terms of the overarching urban world that we live in. So, focusing on the urban infrastructure in the city of Boston, and that it's actually works out well in many different ways to increase density. Glazing percentages, some simple concepts here. There's nothing to say that you can't go for more than the 25% window to wall ratio, but again, it just means you're probably going to end up with a little bit more of a robust building and more expensive building. So you're probably going above that cost analysis that we found. And then also just looking at thermal bridging and R values, some kind of key simple concepts of how we can start to help mitigate thermal bridge in the wall assemblies. And then going back to air tightness, looking at how we can effectively achieve that CFM target that we're looking for, which is based on passive house. Ventilation best practices, just looking for a good balanced ventilation and constant ventilation, because we're also looking at these in terms of indoor air quality and energy efficiency. So health and wellness is also a concern, and it's important that we make sure that it's implemented in these buildings. And then we start to look kind of deeper, more at some building assemblies. So what does the bare bone assembly look like versus the stretch code versus the more efficient zero emissions assembly? And then we start going into can we actually exceed that zero emission assembly? So, if you want to push your building to beyond passive house or contribute to that portfolio in an even larger way, then these are ways to kind of help get there. So I'll just touch on typologies and march through one selected typology and show you how we're presenting the analysis. So again, these are the 4 typologies that we looked at. And then we'll highlight the 4 to 5-story multifamily building. So here are the case study results. And this goes back into relation with the cost analysis. So everything in the background is that Colin and I modeled are actual products that are available on market. And for the stretch code, we took a look at kind of what a lot of current projects are using in terms of assemblies, windows, domestic hot water systems, and then also tying that back to general assemblies. And then the results are highlighting what it will take to get there in terms of your overall U value, your solar heat gain coefficient, what makes a building comfortable in terms of solar heat gain, the window to wall ratio, air tightness, heat recovery, efficiency, domestic hot water system, overall heating systems, roof, wall, and floor R values, and the 75% PV that we're looking at in order to contribute to the overall portfolio. And then at the bottom, it's the incremental construction cost that we found and the incremental operational cost that we found. So again, here are the model assemblies that I was speaking about. We actually left off the manufacturer's names, but again, these are real products that are available to the market, because we want to make sure that these buildings can be accomplished now, and we're not going to rely upon any future technologies or products that may not be available right now. We wanted to make sure that this was achievable, on this very day. And then this is highlighting what the assemblies we modeled. So here we look at the overall zero emission building assembly that we modeled through the parametric modeling software and the stretch code building. And then this is actually taking a look back at what the massing looked like, what its orientation was, what its percentage of glazing and U value and solar heat gain were. And then overall, we conclude with a series of recommendations in order to reach the standard. So what we wanted to highlight was the window to wall ratio being a significant factor, the window U value being a factor, and again, highlighting air tightness as being one of the major factors to achieve these. So now we can go into general questions and feedback. I'm sure there are many.
I've been watching the questions come up. I can bring a couple.
Sure.
I've been trying to keep up. It's coming in both the chat window and the Q&A. So I'm coming at it from all sides. Let's see. I'm looking. John Dalzell asked, would you consider a 2x6 wall with exterior continuous insulation? And is there an EUI for the case study results? To the first one, in terms of the construction, Travis, you guys are the builders. My take on that question is that we're fairly agnostic as long as the R value is achieved. I think you proposed the most cost-effective means to that end, but we're not specific enough to say you must build this way. But go ahead.
Yeah, that was the idea of just showing an R value per assembly. So we do show those kind of basic wall sections that you can use to get there, but the overall R value is what's most important.
And then the second question, is there an EUI for the case study results? Yeah, I thought we'd included that in there, but if we didn't, we can.
In that early chart, we do have the EUI for the case studies. Yeah.
Okay. Yeah. But I should highlight that the intention of the case studies was really a means to an end. I think there was another question I saw before about comparing, I think it was like a 6 unit to the 14 unit. And there is some data to churn over there, but really the intention of those 4 topologies wasn't to say like, hey, you're doing a 14 unit, this is exactly what you need to do. The idea was setting a standard that applied to these kind of general categories of buildings. So if you see something that seems unfair to one compared to another, I think that's a really relevant point to bring up. Basically what we were seeing is from a small building with larger envelope area, the envelope requirements should be slightly more stringent to a large building where there's much lower wall to floor area ratio. Maybe some of the envelope requirements loosen up a little bit just because insulation doesn't do as much at that point. So I guess if you want to focus on the comparison, that would be really useful feedback if you catch any trends that look weird. Next one, was there a % cost increase or value identified for hitting the best air tightness? I know that's always it's a really good question. I've heard that we've had that question turn up a bunch of times. Travis, I think you could go ahead and give your answer with it. We found that there's a learning curve. Once contractors do it the first time, it becomes standard practice. But there is a learning curve the first time.
Yeah, I think it comes back to sort of best practice and that QA/QC. So having the site lead or maybe even a specific person on staff that will kind of help trace that line of what the air barrier is and making sure that it's met. Another way to do that is to look at testing milestones. So you could do a rough blower door test. So after you finish your rough inspections, do a blower door and kind of march through with a smoke stick and get everything that you can there. So you're not relying just solely on the final blower door. And that's especially more so in the smaller typologies where I think that's probably less common. In a larger building, it's more common probably in the commissioning. And that's another thing to look at too, is the overall commissioning of the systems at the end as well. I think that's another important thing to look at as far as that kind of quality control, quality assurance goes. And from our side, we say you never can build a building too airtight. So, I mean, it actually will help free up some of the other assemblies if you can achieve airtightness that might even be better than that 0.06. It'll lessen the load of the heating systems, the cooling systems, and there's lots of other variables that can come into play.
There's a follow-up question about domestic hot water that I thought we had answered, but it says there was a question about the cost of natural gas versus the cost of electricity for producing domestic hot water. And the attendee is saying, yes, electricity is more expensive than gas. They find that it's misleading that we're saying it's cheaper to operate the building without natural gas. And the important point here is the efficiency of the domestic hot water system. So if, let's say, just a high level example, let's say gas is 3 times cheaper than electricity. Gas has a maximum efficiency of about 95% or so. And if you're using a domestic hot water heat pump, an electric heat pump, your coefficient of performance or your efficiency is about 300% up to about 500 or 600%, meaning that for every unit of energy you put in, you get 3 to 5 units of energy out. So even though the cost of the fuel source and electricity is more expensive, you're using by a raw BTU count 1/3 to 1/5 of the use that you would be using should you employ natural gas. So yes, the rate is higher for electricity than natural gas, but when you use it much, much more efficiently, the end cost to the user goes down. And I can say that firsthand. We used to have a natural gas water heater in our house, and right below me, there's a heat pump hot water heater that has been saving us money since we installed it. So, yeah.
So Colin, this is Jay, is there a case where the domestic hot water heating might be more efficient for smaller buildings versus larger buildings?
That's a good question. Yeah. In terms of like larger scale buildings, finding air to water source heat pumps that will work for that scale becomes tricky. There's some clever ways to do it that we're seeing coming about on the market that don't necessarily have a cost premium. Obviously, decentralizing your system so you can use smaller units is one of them. Another option is projects are actually ganging together VRFs, which can be air to water source in a single utility room. Another, I don't think I'm supposed to say, brand names and stuff probably on this, but there's one of the major commercial HVAC companies recently bought a European company that has been producing this stuff for a while. It's a ubiquitous company, so they have large scale air to water source heat pumps. So maybe a year ago a lot of this stuff wasn't available, but long story short is that technology is here, and I think we're all going to be seeing a lot more of it soon. The next one is Boston has many neighborhoods which actually make building multifamily very hard. For example, JP, where the neighborhoods are adamant about keeping their single or 2 family homes. So what are you going to do about giving advice to builders of this topology, which you haven't included in your study? 1 or 2 family homes. I guess, to that question, I'm less familiar with the D&D's portfolio, but in terms of 1 and 2 story homes, is that under the D&D's purview?
It is. We actually are. We actually have some typologies that we're working on with the Housing Innovation Lab that are buildings that are, more units, something between the 4 and 16 unit buildings that also fit into a 2-family context. So there has been some investigation of that. but we don't quite often see, larger or even mid-sized multifamily buildings going into two-family neighborhoods.
There's a question about what software we're using. We just used the WFI software, residential energy modeling. Well, not only residential, but primarily used for residential purposes. We did WFI Plus, and then we have kind of a hack for it to run batch simulations. Does D&D participate? Oh, sorry. Does D&D anticipate that zero emissions review process will be part of the Article 37 review process?
I know that BPDA is going to be working on a zoning process for carbon neutral buildings that are that comply with Article 80, that are that size. So there is something coming down the line. In the short term, I think as Colin suggested, we're trying to make this more prescriptive and not necessarily something you have to get an energy modeler. But there is a equivalent zoning process that's going to be starting up. And we can maybe have some answers for that on the next session with John Delzo.
I wonder, it sounds like there's some, I'm looking through here, there sounds like there was some further skepticism about, I'm having trouble following stream, but it says that isn't true according to our modelers or engineers. If you guys have kind of a technical case to make on it, I think our contact info is included here, and we love numbers, so we certainly work these over a lot of times, and we'd gladly welcome yours. So please send over your thoughts or your calcs or whatever.
Yeah, any specific questions or concerns in terms of content also can go through that feedback portal on the website, because that's where we're on D&D's website, because that's where we're collecting all that into one document. So it'd be good if you can refer back to that to enter any specifics so that we can address those and collect them.
A couple more comments. What about existing buildings? If you look through the City of Boston's carbon neutrality plan, there's a whole chapter about existing buildings. This specific scope doesn't focus on that, but that's certainly on the collective radar. I thought that quote from the mayor was really relevant, where he says, any new building we build, this building will have to retrofit. So this idea is like neutralizing new construction. But of course, existing buildings are on the city's mind. And again, there's a good amount of writing about that. And then the next one says, I applaud the effort, but LEED is prescriptive and my LEED buildings are the worst in our portfolio. So I'll tag that one. That's a bit of a head scratcher of a note there. So all prescriptive means is that it's a requirement for your walls, your windows, your systems. LEED has a few energy paths. There's I think 3 or 4 of them. Some are performance, some are prescriptive, but all of LEED is not prescriptive. And LEED, in terms of energy performance requirements, has a whole range, anywhere from meeting bare bones compliance to earning 20 points. That's a bit of a simplification to categorize all LEED buildings under one hood. The focus on these prescriptive requirements is in terms of energy performance, and through modeling, we're hoping that what we're seeing as the results of these prescriptive standards will in fact perform as such.
All right.
I think we have time for maybe one more question. We're getting up to the 3 o'clock hour, so. We also wanted to put some questions back at the audience. So maybe you could take a screenshot of these, or I think we'll be able, Jenny, I think we'll be able to share this slide deck with everybody. So,
Oh, one more point. Sorry, I just saw Allison brought up, if we have like 2 seconds. She says, can you emphasize that you're not overriding the modeling? If somebody models a good building, then great. Yeah, absolutely. 150%. I'd be out of a job, quite frankly, if we were discouraging energy modeling. The purpose of this study, again, is to provide a resource for folks that aren't doing that. So, but if you are doing energy modeling and you're showing superior performance, more power to you.
yeah, by all means, we don't want to discourage people from doing even better performing buildings. You know, this is about addressing climate change and taking action. So if you're someone that wants to take even more action and push the envelope, so to say, in terms of building performance, by all means, we're going to back you 100%.
And just really quickly about existing buildings, Allison at the in the Environment Department is also working on an existing building strategy for Boston.
Okay.
Great.
Okay, well, thank you guys for this, and thank you everyone who participated. And yes, we are happy to share the slides. This is also being recorded, and we'll be able to also, again, share the link to the guidebook that you can view online, where you can also see places to submit that. So we will be back in touch with everyone who signed up for this sometime early next week with that information. So thank you to D&D, thank you Travis, thank you Colin, and thanks everyone. Well done.
And thank you guys for the critical input.
Thank you. Yeah, thanks.
Have a good, safe weekend, everyone.
And thank you for hosting.